Welcome to Sports and Science. I'm your host, Naomi Norman, and today I will be dissecting a tennis match. For simplicity's sake, we will further refer to the player farthest away from the camera as player 2 and the player closest to the camera as player 1. Player 1 hits the ball with his racket and displaces the ball about 70 feet. Displacement is the amount of distance that an object moves from its original location. Displacement is different from distance because distance is the amount of total distance an object moves. Distance could be 2 steps forward, 1 step back, and amount to 3 steps, while displacement would only be 1 step. In this example, player 2 pushes into the ground with his feet, and because of Newton's third law, for every action there is an equal and opposite reaction, the ground pushes against the player to propel him towards the displaced ball. The relationship here between ground and player is that of force onto ground by player and force onto player by ground. After player 2 hits the ball and changes its direction, the ball accelerates towards player 1. Acceleration is the act of an object increasing or decreasing in velocity or changing direction. Player 1 moves to the ball and hits it with his racket, propelling it towards player 2 again. This is an example of Newton's first law. This law states that an object in motion will stay in motion unless acted on by an unbalanced force. In simple terms, if player 1 didn't hit the ball, theoretically it would continue to fly through the air and through the galaxies until it ran into the wall or a very unfortunate person. We've talked a little bit about velocity, but let's define it and compare it with speed. Velocity is the measure of distance versus time of an object's motion. Velocity is a vector quantity, which means it has direction. Without direction, which can take the form of a positive sign, a negative sign, or worded directions, velocity becomes speed, because speed is the measure of distance versus time of an object's motion without direction. Average speed is just what it sounds like. It's the average time it takes an object to travel a certain distance. In tennis, we use balls with little mass because of inertia. Inertia is the resistance of an object has to changing direction or changing speed. The more mass an object has, the more inertia it possesses. If we were to use basketballs for tennis, we would have to hit the balls much harder because it would require more force to overcome the inertia of the more massive balls. Newton's second law says that when player 1 hits the ball moves in the same direction that the player hits it and with the same amount of velocity as the player's racket. The velocity might decrease slightly because of the ball's inertia, which is dependent on its mass. Mass is the measure of resistance to acceleration that an object has. The relationship between mass and acceleration is that of multiplication to equal the net force acting on the object. If mass is 2 and acceleration is 4, then the net force would be 8. Weight, however, is different from mass because weight is the measure of force acting on an object. An object's weight fluctuates depending on the surface they are on, but mass is always the same. Now let's talk about the vertical and horizontal motion of the ball. In the context of projectile motion, which is the movement that an object makes while flying through the air, the horizontal motion of a projectile shows the constant horizontal direction an object will fall, and as for vertical motion, it is the same concept, but the object will fall vertically. Vertical and horizontal motion are completely independent of one another. If we stand in one spot and toss a ball straight up, it will come back to you. That's probably and hopefully not a surprise. But the ball also falls right back into your hands even if you are moving sideways the whole time. Similarly, when a tennis player is getting ready to serve the ball in the tennis match, they throw the ball up and it falls right back down. That idea also connects with the concepts of horizontal and vertical motion. The vertical up and down motion of the ball is not related to the horizontal sideways motion. The relationship between force and mass here is when the racket hits the ball and exerts a force upon the ball, and the mass of the ball affects how far it travels. This is why, when you tomahawk your racket and smash the ball, it travels farther, while if you were to apply the same aggression to a bowling ball, it wouldn't move as much. Thank you for tuning in to Tennis is a Science. Catch us never again live!